హలో ఎవ్రీవన్, పబ్లిక్ ఎగ్జామినేషన్లో క్వశ్చన్ నెంబర్ 7 మనకు ప్రొడక్ట్ ఆఫ్ వెక్టార్స్ టాపిక్లోంచి ఒక 2 మార్క్స్ క్వశ్చన్ ఫ్రేమ్ చేస్తాడు. ఇక్కడ మనం డాట్ ప్రొడక్ట్ తర్వాత క్రాస్ ప్రొడక్ట్ ఆఫ్ వెక్టార్స్ కాన్సెప్ట్స్ క్లారిటీగా ఉండాలి. అట్లాగే ఫ్రీక్వెంట్గా ఏరియా ఆఫ్ ట్రయాంగిల్, ఏరియా ఆఫ్ పారలోగ్రామ్ మోడల్ క్వశ్చన్స్ ఇస్తున్నాడు. నెక్స్ట్ ప్రొజెక్షన్ కాన్సెప్ట్, రిలేషన్ బిట్వీన్ డాట్ ప్రొడక్ట్ అండ్ క్రాస్ ప్రొడక్ట్, వీటిపైన ఎక్కువ ఫోకస్ చేస్తున్నాడు. ప్రీవియస్ ఇయర్స్లో మనకు పబ్లిక్ ఎగ్జామినేషన్లో ఇచ్చిన క్వశ్చన్స్ను బేస్ చేసుకుంటూ మనం ప్రాబ్లమ్ సాల్వ్ చేసుకుంటూ వెళ్దాం. See here, there are two vectors a bar and b bar. Then show that a plus b and a minus b are perpendicular given. You know that two vectors are perpendicular, then their dot product equal to 0. So here, if dot product equal to 0, then we can say that the two vectors are perpendicular. First we need to find a plus b and a minus b, and after that we have to find dot product of the two vectors. Here it is given that first vector a bar, it is I plus 2 times of j minus 3 times of k. Another vector b bar, that is 3 times of I minus j plus 2 times of k. Next I am going to find a plus b, and after that a minus b. Combination of these two vectors 3i plus I, that is 4i, 2j minus j, that is plus j, minus 3k plus 2k gives minus k. Next a minus b, I minus 3i, that is minus 2i, 2j minus of minus j, that is 3 times of j. Next minus 3k minus of 2k, that is minus 5 times of k. These are a plus b and a minus b. Now let us find dot product of a plus b and a minus b. Dot product of two vectors here, 4i plus j minus k dot product with minus 2i plus 3j minus 5k. Next, you know that if a bar b bar are any two vectors, then their dot product is defined by a1 b1 plus a2 b2 plus a3 b3. That is the combination of product of I jk components. a1 a2, that is 4 into minus 2 here, b1 b2 1 into 3, next plus c1 c2 minus 1 into minus 5, so that it is minus 8 plus 3 plus 5, so that it is minus 8 plus 8, that become 0. Since here dot product of two vectors is 0, implies I can say that a plus b comma a minus b, they are perpendicular vectors. Let us move to the next one. There are two vectors which are perpendicular, then find the value of lambda is given. Let us suppose first vector is a bar and it is given by 2i plus lambda j minus k. Another vector b bar, that is 4 times of I minus 2 times of j plus 2 times of k. Since these two vectors are perpendicular, a perpendicular to b vector implies I can write their dot product equal to 0. Now the dot product of these two vectors, 2i plus lambda j minus k dot product with 4i minus 2j plus 2k, it is equal to 0. Implies dot product of these two vectors, 2 into 4 plus lambda into minus 2 plus minus 1 into 2, it is equal to 0. So that we get 8 minus 2 lambda minus 2 equal to 0. Implies 6 minus 2 lambda is 0 or 2 lambda minus 6 equal to 0. Implies 2 lambda is 6 and hence the value of lambda equal to 3. So this is the solution. Whenever two vectors are perpendicular, then their dot product equal to 0, remember. The same model question, two vectors are perpendicular, then find lambda. Yes, let us suppose first vector a bar, that is lambda I minus 3j plus 5 times of k. Another vector b bar, that is 2 lambda I minus lambda j minus k. These two vectors are perpendicular. Since a vector perpendicular to b implies, I can say that their dot product equal to 0. Implies lambda I minus 3j plus 5k dot product with 2 lambda I minus lambda j minus k, it is equal to 0. Implies lambda into 2 lambda square minus 3 into minus lambda, that is plus 3 lambda, 5 into minus 1 minus 5 equal to 0. There is a second degree equation in terms of lambda. If you factorize this, we get 2 lambda square plus 5 lambda minus 2 lambda minus 5 equal to 0, you can write. If you take 2 lambda common, we get lambda minus 1, and if you take 5 common, lambda minus 1 is 0. Implies lambda minus 1 multiplied by 2 lambda plus 5, it is equal to 0. So that the value of lambda equal to 1 or the value of lambda equal to minus 5 by 2. This is the solution for lambda. Next, two vectors are parallel, then find P. You know that when two vectors are parallel, suppose a bar b bar are two vectors, and if these two vectors are parallel, you know the condition, one vector is scalar multiple of the other, and that can be written as a1 by b1 equaled a2 by b2 equaled a3 by b3. Here let us suppose given two vectors are a bar comma b bar. A bar is given by 4i plus 2p by 3j plus pk, and another vector b bar here I plus 2j plus 3 times of k. Here a vector parallel to b vector. Since these two are parallel implies you can write a1 by b1 equal to a2 by b2 equal to a3 divided by b3. Implies you can write 4 divided by 1 equal to here 2p by 3 divided by 2 equal to p divided by 3. That is the value of p by 3 equal to 4, and hence p become 12. This is the solution. Next question. Length of a plus b equal length of a minus b, then find the angle between a and b. Since length of a plus b, it is equal to length of a minus b, then I can write square of their lengths also equal. Mod a plus b whole square equal to mod a minus b whole square. Now on expansion we get mod a square plus mod b square plus 2 times of a dot b. Next, mod a minus b whole square value modulus a square plus modulus b square minus 2 times of a dot b. Neglecting modulus a square modulus b square on both the sides, we get 2 times of a dot b, that is equal to minus 2 times of a dot b. Implies we can write 4 times of a dot b, it is equal to 0. Implies dot product of two vectors is 0. When dot product of two vectors is 0, then we can say that angle between the vectors a and b, that is 90 degrees. So this is the solution for this question. Let us move to the next one. A bar, b bar are two vectors. Find the projection of b on a and its magnitude. I am going to write the formula first. You know that projection of b bar on a bar, projection vector you need to write, and after that magnitude, projection vector of b bar on a bar, that is here the formula a dot b divided by b on a is given. In the denominator part you have to write modulus a and a divided by modulus a, that is a dot b into a vector divided by modulus a whole square. A dot b first you have to write. Here in the given question a vector is I plus j plus k, dot product with b bar 2i plus 3 times of j plus k. After completing the dot product, you have to multiply this with a bar. A bar is I plus j plus k. Next, in the denominator part, length of a whole square, only a square plus b square plus c square. Given that here a vector is I plus j plus k and b vector is 2i plus 3j plus k. Modulus a whole square here 1 square plus 1 square plus 1. Dot product of these two vectors 1 into 2, 2, 1 into 3, 3, 1 into 1, 1, multiplied by I plus j plus k whole divided by 3 it is. 6 by 3, that is 2 times of I plus j plus k it is. This is projection vector of b bar on a bar. Next, you need to find magnitude. Magnitude of projection of b bar on a bar, that is equal to modulus of 2 times of I plus j plus k it is. 2 outside, length of I plus j plus k, that is root over a square plus b square plus c square, that become 2 times of root over 3. So this is projection vector as well as length of or magnitude of projection vector of b on a. See this question, find the angle between the vectors I plus 2j plus 3k and 3i minus j plus 2k. Angle between two vectors is given. Let us suppose first vector a bar, that is I plus 2j plus 3k. Another vector b bar, that is 3 times of I minus j plus 2 times of k. Next, angle between two vectors concept. By angle between two vectors, you can write cos theta as a dot b divided by modulus a into modulus b, and from this you will get cos theta equal to first a dot b in the numerator, that is I plus 2j plus 3k dot product with another vector b bar, that is 3i minus 2j, sorry, minus j, it is minus j plus 2 times of k divided by length of a, length of I plus 2j plus 3k, length of b, that is modulus of 3i minus j plus 2k. On solving this, we get cos theta equal to, first in the numerator, dot product of these two vectors, 1 into 3, 3, 2 into minus 1, minus 2, 3 into 2, that is 6, whole divided by, next root over 1 plus 4 plus 9 it is, next root over 9 plus 1 plus 4. In the denominator, root 14 gives 14, and in the numerator 9 minus 2 gives the value 7. Therefore, it is 1 by 2. When cos theta equal to 1 by 2 implies theta equal to, it is 60 degrees, or you can write pi by 3. Cos 60 degrees value 1 by 2. So, theta becomes 60 degrees, or you can write pi by 3. Next question. A bar, B bar are two vectors and theta is angle between AB. Then find sin theta is given. First, you can write cos theta formula A dot B by mod A mod B, and then with the help of trigonometric identity, you can get sin theta. A bar is given by 2i minus j plus k. B bar another vector, that is 3i plus 4j minus k. Next I am going to write cos theta, that is A dot B divided by modulus A modulus B, implies cos theta written as first dot product of A bar and B bar. Here A1 A2 2 into 3, B1 B2 minus 1 into 4, C1 C2 1 into minus 1, whole divided by modulus A value root over 4 plus 1 plus 1. Next modulus B root over 9 plus 16 plus 1. And from this you will get cos theta value. Here it is 2 3 is 6. Next minus 4 minus 1 whole divided by root over 6 into root over 26 it is. 6 minus 5, that is 1, divided by root 6 into root 26. This is the value of cos theta. But here the aim is to find sin angle. Now I am going to write sin theta. Sin theta written as root over 1 minus cos square theta it is. Implies you will get sin theta value root over 1 minus cos square theta from this 1 divided by 6 into 26, implies sin theta written as root over 6 into 26 minus 1 divided by 6 into 26, implies the value of sin theta become 6 into 26 value 26 into 6 root over 156, that is. So here in the denominator part we get 156, and it is 156 minus 1 become 155. Therefore sin theta value become root over 155 divided by 156. Let me cross check. A bar 2i minus j plus k, B bar 3i plus 4j minus k. Dot product kada 3 to just 6, 4 into minus 1 minus 4 minus 1. So 4 minus 5 become 1. In the denominator part 4 plus 1 plus 1 root 6, 9 plus 16 plus 1. 9 plus 16, 25, plus 1, 26. Yes, 156 product of these two. So 155 root over 155 divided by 156. Sin theta written as root over 1 minus cos square theta, remember. Next question, length of A, length of B is 5 and A dot B equal to 60. Then find A cross B is given. You know that modulus A cross B whole square equal to A square B square minus A dot B whole square. This is the standard result. This is the relation between cross product and dot product. Here modulus of A cross B whole square now written as mod A whole square is 13 whole square into modulus B whole square is 5 square minus A dot B whole square is 60 whole square. Why? Because already given in the question, since modulus A equal to 13, modulus B equal to 5 and A dot B it is equal to 60. Yes. Now you can write mod A cross B whole square equal to, it is 13 square into 5 square, 60 square written as 12 square into 5 square. From the both, if you take 5 square common, what happens? Inside 13 square 169, 12 square 144. Therefore, mod A cross B whole square is 5 square into, from 169 if you remove 144 we get 25. 25 written as 5 square. Now only modulus A cross B if you write, that is 5 into 5 become 25. So that modulus of A cross B is 25 in this case. Next, area of the parallelogram with adjacent sides is given. You know that if there is a parallelogram with adjacent sides A bar and B bar, then its area is denoted by, area is modulus of A cross B when adjacent sides are given. This is the area of parallelogram. Here I can write area of parallelogram, that is modulus of A cross B. So here modulus of A cross B value I am going to calculate I, J, K. Here in the question given that A vector, that is 2I minus 3J, B bar components given by 3 times of I minus K. Yes, A bar components 2 minus 3, 0, B bar components 3, 0, minus 1. First find internal part, determinant of I, J, K, 2 minus 3, 0, 3, 0, minus 1, and then find its length, that gives area of parallelogram. I into minus 3, 0, 0, minus 1, next minus J into 2, 0, 3, minus 1, next plus K into 2, minus 3, 3, 0, and for which we have to apply modulus. Here it is 3 times of I. Next, minus 2 into minus J, that is plus 2 times of J. These two, product of 2 and 0 is 0, minus 3 into 3, minus 9, one more minus sign is there, so that 9K with modulus sign. Now under root of 3 square value 9, 2 square value 4, 9 square 81. So that area become root over 81, 9 plus 4 13. So root 94 square units is the area. Area of parallelogram formula just modulus of A cross B. If the question is to find vector area, then no need to write modulus sign. Up to the vector we get the result. If the question is simply area, then that should be scalar quantity, so you have to apply modulus sign. If the question is to find vector area, remember that no need to write modulus sign. Only 3i plus 2j minus 9k vector gives the vector area. Next, find the area of parallelogram whose diagonals are given. If suppose diagonals of a parallelogram are given, this is D1 and suppose this is D2, then area of parallelogram that is half into D1 cross D2 with modulus sign. This is the formula for calculating area of parallelogram when diagonals are given. Given that diagonal 1 and diagonal 2, diagonal 1 is 3i plus j minus 2k, diagonal 2 I minus 3j plus 4 times of k. This is 1, this is 2, and this is the formula for area of parallelogram when diagonals are given. Here first I am going to find D1 cross D2 value, I, j, k. Next, components of D1, 3, 1, minus 2. Next, you have to write the components of D2. D2 components here 1, minus 3, 4. Therefore, D1 cross D2 become I of 4 minus 6. Next, minus j of 12 plus 2. Next, plus k of 9 minus 9 minus 1 it is. I multiplied by 4 minus 6 minus j multiplied by 12 plus 2. Next, k multiplied by minus 9 minus 1. So D1 cross D2 become minus 2i minus 14j minus 10 times of k it is. You can take 2 common from this. Therefore, D1 cross D2 equal to, if you take minus 2 common, we get I plus 7j, next plus 5 times of k it is. Next, modulus of D1 cross D2 gives, modulus of minus 2 is 2, and modulus of this vector root over 1 plus 49 plus 25. This is D1 cross D2, but we need half into modulus D1 cross D2. So if you transfer these two here, half into modulus D1 cross D2 gives root over 75. This is clearly the formula for area of parallelogram. Therefore, area of parallelogram is root over 75 square units. That's all. Let us move to the next one. A bar, B bar are given. Find modulus of A cross B. That is the question. Simple question. Just we need to find A cross B first and then we go for its length. Given that A vector is 2i minus j plus k and B vector that is I minus 3j minus 5k. First A cross B I am going to find I, J, K, A bar components 2, minus 1, 1, B bar components 1, minus 3, minus 5. Implies we get the value of A cross B. I of, first it is 5 plus 3. Next minus J of 2 into minus 5, minus 10, 1 into 1, minus 1. Next K of 2 into minus 3, minus 6. Next plus 1. Implies A cross B become. Here determinant part we need to find with plus minus plus sign. I multiple by closing corresponding row column we get a submatrix. Its determinant here you have 5 plus 3. Next minus 10 minus 1. Then minus 6 plus 1. This is 8I. Next plus 11J minus 5K. Length of modulus of, that is length of A cross B, that is root over 8 square 64, 11 square 121, minus 5 square 25. 121, 64 of all the three. This is 210. So that you can write length of A cross B, that is root over 210 square units. That's all. Let us move to the next one. Find the unit vector perpendicular to the plane containing two vectors A bar and B bar. Very important question. A plane that contains two vectors A bar and B bar. Then we need to find unit vector perpendicular to the plane containing these two. Its perpendicular vector is denoted by A cross B. But the aim is unit vector. Only one unit vector, that is denoted by n cap equal to A cross B by modulus A cross B along with plus or minus sign. That formula now we have to use. Since A vector is 4I plus 3J minus K, B bar is 2I minus 6J minus 3K. Then first I am going to find A cross B. I, J, K. Here the components are 4, 3, minus 1, 2, minus 6, minus 3. Let us find A cross B first. A cross B equal to I component multiplied by submatrix here minus 9 plus minus 6 into minus 1, that is plus 6, but in between them minus sign, so that minus 9 minus 6. Next minus J of 4 into minus 3 minus 12, 2 into minus 1 minus 2, between them again minus sign, so that you will get plus 2. Next K component minus 24 minus 6. Therefore A cross B equal to I of minus 15 minus J of minus 10 plus K of minus 30. Therefore the vector A cross B written as, if you take 5 common, what happens? Minus 3I plus 2J, next minus 6 times of K it is. This is A cross B. Modulus of A cross B also I am going to find. Modulus phi is 5. Next length of this vector root over 9 plus 4 plus 36. Root over 49 value 7. 7 into 5, that is 35. A cross B over mod A cross B also over. Here unit vector perpendicular to both a bar comma b bar. That is required unit vector equal to n cap denoted by plus or minus a cross b divided by modulus a cross b it is. So that what we get, plus or minus a cross b here 5 times minus 3i plus 2j minus 6k whole divided by 35. On simplification, it gives the result plus or minus 1 by 7 into minus 3i plus 2j minus 6k, or simply you can write plus or minus 1 by 7 3i minus 2j plus 6k also. Take negative sign common, you will get final answer. See this question, find the angle between the planes. This is also very important. Angle between two planes is defined by angle between their normals. Here plane 1 is given by r vector dot 2i minus j plus 2k equal to 3. This is first one. Second plane pi 2 r bar dot 3 times of I plus 6 times of j plus k, it is equal to 4. This is second one. Next, angle between two planes is defined by angle between two normals. The definition I am writing, angle between two planes is angle between their normals. So that cos theta formula can be written as n1 dot n2 divided by modulus n1 into modulus n2. This formula I am going to use. Here these two are n1 and n2. Now cos theta equal n1 first vector 2i minus j plus 2k dot product with 3i plus 6j plus k divided by length of n1 length of 2i minus j plus 2k, length of n2 modulus 3i plus 6j plus k. Now cos theta equal to dot product of these two vectors 2 into 3 6 minus 1 into 6 minus 6 2 into 1 plus 2 whole divided by length of this vector root over 4 plus 1 plus 4 first one, n2 length 3 square value 9, 6 square value 36 and then 1. 3i plus 6j plus k is given. Now cos theta can be written as 2 divided by root over 9 root over this is 46. Therefore cos theta equal to 2 divided by 3 root over 46. Angle between planes theta, so that you can write cos inverse of 2 by 3 root 46. Finally we need to write just the angle theta. If the question is find cosine angle, then you have to write cos theta. But here the question is find the angle. Angle means theta, finally you have to write. Next question, find plane passing through the point perpendicular to a vector. Plane is passing through a point. What is that point? 3 comma minus 2 comma 1, and given that it is perpendicular to a vector 4i plus 7j minus 4 times of k. Find the plane passing through is given. Maybe the equation in terms of Cartesian system, or you may write in vector system. It is better to go with Cartesian system. required plane passing through a point A x1 y1 z1 and having direction ratios of normal A comma B comma C is defined by A of x minus x1 plus B of y minus y1 plus C of z minus z1 equal to 0. It is Cartesian form of equation of plane. ABC are 4, 7, minus 4. Next x minus x1, that is x minus 3. Next y minus minus 2, y plus 2 here, and then z minus 1 equal to 0. So that what we get? 4x plus 7y minus 4z, and next 4 into minus 3 minus 12, 7 into 2 14, minus 4 into minus 1, that is plus 4, 18 minus 12, that is plus 6 equal to 0. This is equation of plane passing through a point and having direction ratios of normal ABC. And in vector form, it can be also written as, I can write 4i plus 7j minus 4k multiplied by r vector. R vector is xi plus yj plus zk. xyz, xi plus yj plus zk, that is r bar. Remaining 4i plus 7j minus 4k plus 6 equal to 0 also you can write. If the question asked in the examination, find vector equation of plane, write final answer in vector form. If there is no such vector equation, simply suppose the question find the plane equation, you may write any one of these two. If particularly find Cartesian equation of the plane, then write the solution up to here itself. If the question is in vector form, then also you have to represent the final answer in terms of vector form. Remember this. So these are the questions, very very important. Mostly the questions based on area of triangle or area of parallelogram. Area of parallelogram modulus A cross B. If the question asked in area of triangle, then write half into modulus A cross B. So these type of questions mostly asked in the public examinations, so that you have to prepare these type of questions only. Thank you so much.